Okay, ladies and gentlemen, welcome to the Same Different board game. The game where you get to spin the wonderful spinner o' fate. And if it comes up with the same, you get a point. If it comes up different, your partner gets a point. All right, you ready to play? Give it a spin, and whoa, look at it go. You got a blue. Okay, spin it again. Wow, that one's even faster, and it came up pink. Oh no, your partner gets a point. 1 point for the partner. Okay, do it again. Give it a spin. And you get green, and come on, green. Oh, pink, your partner gets another point. All right, first to five wins. Let's go again. And good spin there. You got a green. Come on, green. Let's see what you get. Oh, look at that. You got a green. So you get a point. Keep going. Yeah, shooting for a tie here. And pink. What do we got now? Good spin. Oh, another point. Look at that. You get a point. Okay, tiebreaker. Here we go. And give it a spin. Pink again. Another spin and blue. Oh, nice try. Thanks for playing the wonderful Wheel o' Fate. But it looks like your opponent came up with the win. You're just a little bit short this day. Thanks for coming. You can go back to your seat. All right. So, what do you think? Was it fair that you had to come up with the same color and your partner had to come up with a different color? Well, let's say leaving the game show, you're a little disgruntled, so you decided to figure out for yourself, like, was this a fair game? Well, you could make a tree diagram like you see down below. Whoops, I accidentally gave the Wheel of Fate another spin. Okay, so a tree diagram. Well, let's scroll a little bit more. There we go. A tree diagram is used to list every possible outcome of an event happening. Okay. That way, you know everything you're dealing with, especially you remember from the last lesson, to get the probability of something, it has to be favorable outcomes over total possible outcomes. So this lets us figure out every single outcome. So we can see, how many, in this case, because our two possible outcomes were how many the same there are over how many total possible there is, and then how many different combinations there are over total possible. So this will tell us both. So when we were playing the game, there was two events happening. You gave it a spin and you recorded a color, and then you gave it another spin and recorded the color. So because there was two things happening, our tree diagram has two columns, basically spin one and spin two, and whatever could happen on them. The third column is just us organizing the answers. Okay, so spin one, what could you get? Well, you could get pink, blue, or green. Okay, those are the only options that can happen on spin one. So I write down pink, green, and blue, nice and spaced out when you're making these. Okay, if this was in your notebook, I would want probably 4 lines minimum between these, maybe even 5. Okay. So on your second spin, you hit it again, and what could happen? Well, same thing, pink, blue, or green. So let's look at how we set this up, and this is what makes it a tree. So on your first spin, let's pretend you got pink. Okay. You go and you hit it again. What could happen? Well, you could get pink, green, or blue. And then that's it. You only get to hit it twice. So let's go back to spin one. Let's pretend instead you got green on spin one. What could happen on spin two? Well, you get pink, green, or blue. And then obviously spin one, you could have got blue. What could happen on spin two? Well, you could get pink, green, or blue. And then it's just organizing your outcomes so that they're easier for you to see. So how to do that? Well, follow this along. So we're starting here, we're at pink, and follow it to the end, pink. So that gives us pink, pink. Start here and go to the next one down, which is along here, green. So pink, green is the next outcome. And go back here, follow it to the next one down, blue, pink, blue. So basically what we're doing is I'm following the path through to each separate endpoint. Okay, and then this will give me green, pink, green, 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 blue. I know it's tough to see with that watermark sitting there. So green, pink, green, 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 blue. And then same here, blue, pink, blue, green, blue, blue. Okay. Now, one of the questions asked is find the probability of getting the same colors. Okay. So probability of getting the same. Our favorable outcome is outcomes that have the same. So I go looking in my first grouping and outcomes with the same. Well, pink, pink. That's pink, green, pink, blue. No, nothing the same there. Green, pink. Oh, green, green. And then green, blue. And then go in my third, and either the same. Oh yeah, blue, blue. So favorable outcomes, I have 1, 2, 3 of them. Okay. Over a total possible of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. For 33%. So now, probability of different colors. So probability of getting something different. Well, it's all the ones without arrows. So there's, let me change colors here. 1, 2, 3, 4, 5, 6 of them. So 6 outcomes where you get something different. That's our favorable outcome. Out of a total possible of 9 still. And that's 67%. So yeah, if you were leaving the the game show completely disgruntled that, your partner won and you lost, well, yeah, I mean, you had a 33% chance of winning. Your partner had a 67% chance of winning. So yeah, the odds were not in your favor. Effie Trinket lied. Okay, so and just before I let you go, if there was like a third outcome, like maybe you got the spinner to go 3 times, you would just make a third column here, and then your outcome would have like pink, 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 and then it would be, actually here, let me show you. So spin 3. So it would be pink, 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 and then this could be pink, green, blue, going off of this one, and then pink, green, blue, blue, not a D, going off of that one. You can see I'm going to run out of room, so I'm not going to keep going. And then pink, green, blue, going off of that one. And then for your outcomes, you would go pink, 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 green, pink, pink, blue. Next outcome would be pink, green, pink, pink, green, green, pink, blue, blue. Or sorry, pink, green, blue. And then pink, blue, pink, pink, blue, green, pink, blue, blue. So you just follow the path all the way to each of the endpoints until you list them all off. And then that's what you would write over here. Okay? So those are tree diagrams. They definitely list every outcome for you, and then you can go hunting for your favorable outcomes to drop those numbers into the formula. That's it. If you have questions, you know how to reach me. Bye for now.